School of AI.
So before you enroll in this course, I want you to watch the free project demonstration. Now in this preview, I will show you a complete autonomous AI application built with Python around a real-world airline use case. Hi, I'm Vivin Arana and I'll be your instructor along with Arjun Ved for this course. Now imagine that a passenger's flight is cancelled because of bad weather. Instead of simply displaying an error message, our AI system receives a clear goal: help the passenger reach their destination as quickly as possible. Now the system begins by understanding the passenger's request. A planning agent breaks the problem into smaller tasks, and then a tool using agent checks available flights, calculates possible travel times, and compares alternative routes. Now, a knowledge agent here searches for the airline's private policies for rebooking, refunds, baggage transfers, and hotel eligibility. Now, a research agent can gather additional information such as weather conditions or airport disruptions. Now, an analyst agent compares the available options, while a reviewer agent checks whether the recommendation follows airline policy and meets the passenger's requirement. Now, before any booking is changed, the system asks for human approval. The final result is not just a chatbot response, it is a complete coordinated workflow powered by multiple AI agents, memory, tools, private documentation, and also retrieval augmented generation. And on top of that, a Python interface. So let's look at this demo project. So whatever we have been talking about here is the actual implementation of this entire project. Here is a completely coded project which is also available in your resources. If you want to download it, you can download this file and then unzip it and then play start from here, or you can follow along with me and try to understand what this project does. Now again, this project, I call it an airline. I think I have more details inside my readme file. An airline disruption AI command center, which is a multi-agent AI system that helps you rebook passengers when flights are cancelled. It runs entirely locally using Ollama, so we don't need any cloud LLM for this, so you don't have to pay for anything. You can run completely locally, and if you need, you can still connect to any OpenAI or any other LLMs that you want. It uses LangGraph for agent orchestration, and it uses ChromaDB. So you'll probably see all the code inside SRC. ChromaDB for policy retrieval, RAG, and Streamlit for the UI. That's what we use for the UI. Again, now to talk more about, let's start from the app.py file. Now this is the Streamlit web application, which is the entry point that you'll start from. So this initializes all the services, your airline database, your memory store, your policy knowledge base, your airline recovery workflow, your airline data, and your airline logs, which we'll probably look at in a few minutes when I run this project. But that's where it starts from, where your recovery workflow describes the disruption, it creates a plan, you can review, approve it, and then run the agents and approve the final rebooking. And also airline data is more for where you can view the raw passenger booking and the flight data. And we have the audit logs where you see every event recorded for the current project. We'll also implement the human in the loop pattern where no booking changes without an explicit human confirmation step will be done, so that you'll probably see when we run this project. Again, this is our Streamlit application, pretty straightforward. If you've probably done it before, that's good. If not, we'll probably be talking more about it in the next 7 days. So let's go ahead and look at our Streamlit, requirements file here. Now, requirements file is all the Python dependencies or your packages are available here. We start with Streamlit, which is your web UI. We have Ollama, which is our local LLM client. We use LangGraph, which is the agent workflow graph or your orchestrator. We have the Pydantic, which is for data validation, structured schemas. We have ChromaDB, which is our vector store for RAG, and we have MyPDF, which is for PDF text extraction. We also use GS, which is DuckDuckGo for web search. We have request, which is for HTTP calls. We have python.env, which is for loading the environment variables from the environment, which we'll be creating soon. And then we have the PyTest, which is our test runner for this particular project. Again, we'll be going through in complete detail in the next 7 days, but for now, I just wanted to introduce you what all we are doing. And again, this is a consolidated project of all the different things that you'll be learning. So this is not something that you can do in one day. Next, let's go ahead and look at the environment example. So this is your template for environment configuration. You can copy this to an environment file and fill your values, but this is just to show me like, okay, where is the Ollama host? What is the model that I want to use? What is the embedding model that I want to use? What is the airline database path? Where is the Chroma database path, ChromaDB path? What max research results should be available? Fine. So you can change that based on your own requirement. I also have the src folder. Inside this is measure of our source code. This is a frozen data class settings in config file, where you have this is, as I call it, a frozen data class settings that holds all the configuration. The settings from environment method here, class method reads from your environment variables with saved defaults and then passed around to every component that needs the configuration that we pick it up from here. Also, if you see, I've used some default values here if the environment file doesn't exist, so it should be safe to run. We also have the schemas.py, so let's go through that file. Schemas.py, this file is the shared vocabulary for the whole system, and it kind of has your Pydantic data models available for everything. So think of it as like your database models if you've worked with those before. Next, we have the LLM. So let's go through LLM-py. This is the Ollama LLM wrapper, which is a wrapper around the local Ollama client. And three key methods here include, let's look at them. I'm going to go over chat. This is very important. Chat is a free text generation with a system and also uses the user prompt. We also have structured here, and this forces the model to return JSON matching, a Pydantic schema that we just saw. We also have embed method here. This generates vector embeddings for a list of text. That's what it does. And I think the ensure available, yeah, which is on the top, which validates the Ollama is running and both models are pulled before the work begins. That's this particular file, our LLM file. Next, we're going to look at our airline DB file, which is this one here. This is a SQLite database layer file with four tables. We have passengers, it will create all those files for us: passengers, bookings, flights, and booking changes. So that all will be created for us. Also have some data that kind of helps me insert some dummy values to start. It has like search flight function which filters by origin, destination, seats and status. It also has the confirm rebooking, which automatically updates booking, plus it decrements the seat count and logs the changes. So all the functions for that are available inside this code base, so inside airline DB. Next important one is memory.py, which is right over here. Now this is a memory store backed by the same SQLite file with again three tables for memory. For the agent memory, we have user preferences, which persist per passenger preference key value pairs, and then we have the conversation messages, which per session chat history, where user and it looks like the user plus the assistant turns. We also have the audit events, which is per project structured event log, where it talks about the plan created, approved, rejected, workflow completed, rebooking confirmed. So that's all the details available in this particular file. You can check this out. Next, we have rag.py. Now this file has the policy knowledge base, which is a retrieved augmented generation system that we have, and it uses ChromaDB as a persistent vector store with the cosine similarity, and that's what we have implemented here. We also have the index PDF method, which extracts like text from the PDF chunk set into 900 character chunks with 150 overlap. I hope you understand that. If not, we'll probably be covering them in the future sessions. We also have it also embeds with Ollama and upserts into the ChromaDB. So that's what it does. We also have the search function here, which embeds a query and returns the top k most relevant policy chunks with source metadata and distances. And it also chunks chunks like the chunks that are created are content addressed, which is SHA-256. So reindexing the same file is idempotent. So that's what it does here, and it's pretty cool the way it is written. So we have all these things available here. Now let's look at our main file, which is agent.py. So the agent.py has the airline agents here class, which has the 5 LLM powerful agents, each with a carefully crafted system prompt. So if you see, We have the planner here, which produces a structured recovery plan for the given goal. Next, we have the analyst here, which ranks supplied flight options and picks a recommendation with a guardrail, of course, that rejects any flight the model hallucinated. We have next one should be the writer right over here. This writes a custom facing markdown recommendation. We have the reviewer here, which again scores the return answers 0 to 100 and flags them. And finally, we have the revise agent, which rewrites the answer addressing reviewer issues. So that's our entire agent structure here. So all the agents are available in this particular file, and that's why it's called agents.py. Next, let's look at tools tools.py. Now again, just from the name, this has airline tools available for us, which is deterministic or non-LLM tools used by the workflow models. So in here we have get passenger and booking. Exactly what it says is it does fetches and validates the passenger and the booking pair. It also has the search alternative flights, and this, as the name says, is delegates to the airline database and calls the search flights over there. Next, we have the calculate option store. This is the heuristic scoring, which penalizes the stops, the long durations, delays, and rewards same cabin and seat availability. We have the enrich and rank flights here. Now this adds scores plus adds the human readable reasons and sorts the results out for you. Next, we also have get weather here. This calls the Open Mateo public API for current conditions. As you can see, I have incorporated that here. Then we have the web search. This runs a DuckDuckGo text search via DDGS, and that's the Python package we just spoke about. And finally, we have the confirm rebooking. This delegates to the database and appends a mock confirmation message for us. So that's perfect. That's the entire tools file. Next, let's look at the workflow.py file. Now, this one, as the name says, this is our airline recovery workflow, which is the orchestration layer. It builds a LangGraph LangGraph state graph over recovery state, which is a type dict holding everything: the plan, the passenger context, the flight options, the analysis, answers, reviews, logs, everything. It has a graph topology where it goes through the workflow of start, passenger, knowledge, then research if required, then tools, then goes to analyst, then the writer, reviewer, and then finally approved and end. The usual structure that we see that happens. Even after if it's not approved, you can go ahead and revise and then goes to reviewer again and up to 2 retries or however many you want. Now there's 3 public methods in this, as you saw while I was scrolling. One is the create plan. The create plan method calls the planner agent, returns the draft state, and it doesn't have uh, so it has no graph run yet here. Next, we have the execute approved plan. What this does is it sets the plan approved to true and runs the full graph for us, and this is where it starts. And then we also have the confirm rebooking, and this function is the final human gated action that actually changes the booking for us. So that's what we have in here. So given that, let's go run to a script. So we have a scripts folder here, and inside this we have the seed data.py. Now this is a one-time setup script that populates the SQL database with demo data that is available. In this particular case, I think I have some passengers, Jordan Lee here, which is gold tier, and he or she is flying from Indiana to San Francisco. Booking number is BK1001. Status, if you see for that, is cancelled. There's 4 alternate flights that are available. So all that information comes here, and we can run this initially to seed this data before the demo that we do today. Next, so that's with scripts. Next, we have test here. Now this test has test airline and test tools, 2 different ones. The test airlines, this is the integration test for the database. It creates a temporary database, inserts a passenger, booking, and flight, and verifies the search flight, returns it, and confirms the full confirmation booking cycle works correctly. So that's what this particular file does. We'll probably be running it and then learning more about how to implement test in the later during this week. And then we have the test tools. Now this is the unit testing for scoring the heuristic, which are asserts that non-stop same cabin on time flight scores higher than one stop wrong cabin delayed flight. So that's the basic stuff that I implemented just for testing purpose, just to show you quickly something in the test side of it. We also have another folder that you see, sample docs, which has a document or some text here. Now this is a plain text mock airline policy document for a fictional airline called as Oceanic Air, which covers, and you probably have heard this name before in TV shows and stuff, commonly used, and it covers rebooking rules, passenger approval requirements, and same day preferences, the meals and hotels, refunds, baggage, and auditability. So this is not a PDF, but its content represents what you'd index via the PDF uploader in the UI. So I did not find, or I could have just converted into PDF file. So how does this all fit together? So when the app.py runs as the Streamlit UI application, it goes through the workflow.py, which is in here, which calls the airline recovery workflow, which calls the airline agents, which is inside agents.py, which calls our Ollama LLM, which is inside Ollama LLM, which calls the Ollama service that is running. So that's the entire flow for it. You can also go to the airline, it might also go to airline tools to look for tools, and then go through the airline database, which is available inside airline underscore DB. Then it can also go to the policy knowledge base, which is inside rag.py. So inside this we have policy knowledge base, and then that can go to ChromaDB, and finally we have Ollama LLM, which can go to memory store through memory.py that we have here, and to the SQLite. So that's the entire flow for this entire application of how it works. Now again, if you did not understand this, don't worry about it. We'll be covering this in more detail in smaller chunks in next 7 days. So everything will be a small single project. This is a consolidated project of all the different things that we will be doing in next 7 days. So let's go ahead to the README file. Now, if you have this file, it's going to talk about this project, and it's also going to talk about what does the demo do. So the architecture that I spoke about, something right now, Streamlit UI, goal intake, and PDF upload, then planner agent, then goes to the LangGraph workflow. I should spoke about this in the code, but this is what is happening as per the architecture goes. The passenger agent, knowledge agent, research agent, depending on that, it will find the right file and go to either tool agent, analyst agent, writer agent, reviewer, and then finally supervisor finish. And that's the entire flow for it. So let's make sure that you have Python installed. So I'm going to go ahead, terminal, new terminal. If first thing is Python, so I'm going to say Python 3 dash dash version. It will give me the version number. So make sure that you have 3.11 or newer. Also install Ollama from ollama.com, or you can just check if you already have Ollama available. You can just say Ollama over there, and it will show you. If it gives you a particular prompt and it doesn't say not installed, you can install Ollama from there. You can also install Ollama model. We are going to use Llama 3.1 latest, but you can look at the website and see which one works best for you. I also going to pull Nomic embed text for embedding purposes. That's the model I'm going to use for embedding. Close that. Again, you can replace with anything that you want, up to you. Now, if you're running Mac OS or Linux, these are the next commands. You go to the folder. I'm already in the folder, so skip that. Create a virtual environment. Then I'm going to activate the virtual environment. So all my packages are installed in the right place in a one single environment for me. And then I'm going to run this. I'm going to close this, make it as bigger as possible. So now it's installing all the different requirements that we have for this project into this particular environment, which is venv that we have created here. Once that is done, I'm going to go ahead and create my environment file. So for that, I'm going to copy this. What this does is it takes whatever is inside this environment.example and create a new file for me, as you can see. And then this is what I can use for specifying which environment or what variables I need from there. I've already created an example for that, and from there I've copied it. If you're running Windows, use these commands. That's what I'm saying is the same thing that I did here for Mac. Next, I'm going to go ahead and run my script seed data. This is, again, as I mentioned, this will create my passenger that we saw, Jordan Lee or someone, and then put all the flight information and different flights available. So I'm going to run that. So it gave me an error saying no module named src, because inside this file we have that module available. So what I'm going to do is, instead of this, I'm going to change this to python dash m scripts dot seed underscore data. So what this will do is this will run it and seed the data, and you'll see the data folder get created and airline db. I don't have any plugin to read the database, so it's going to show like that, but that's how I can run it. Again, clear? So make sure I update this, and you can update this based on your system. So this will create my passenger, and then now next I'm going to go ahead and add my policy knowledge. So we have the sample docs. So for to demonstrate the PDF rag, you can save this as a PDF file, but I'm just gonna use this here. And now finally go ahead and run my Streamlit. Now again, this might give me an error too. No, it worked perfectly here. It gave me error because again I have to run it as a module. So I'm gonna go back, close it here, dash m Streamlit run app .py. So either this command or this command, the other command will try to give you problems because of the local modules that are running. But there you go, our entire project is ready. It's saying here Ollama must be running locally before planning or execution. So I have my Ollama running here, but it might sometime not be serving out there. So I'm going to let check it out as and when it goes here in this particular demo. So we have the passenger information, the booking ID, and we can also upload some airline policy PDF files. We already have the PDF file, so I don't have to actually go ahead and upload, but you can index it and you can add your file here. So we will be using the local text file that we have, and I'd say use web research here and start a new project from here. So here is my entire flow. Now I have my airline disruption AI command center here, as it says what all it's using. I'm going to go to the recovery workflow here and describe the disruption. I've already pre-filled it for us. My flight BK1001 was cancelled. Help passenger P1001 reach SF4 today. Prefer the fewest connection and avoid an overnight stay, and do not make a booking change until I approve it. So I'm going to go ahead and create the recovery plan. It's going to run, it's going to call Ollama, and it's going to try to give me an recovery plan as soon as it gets it from the Ollama model. Here you go. The plan produced a validated recovery plan where I have my goal summary, my assumptions, my steps that I can do: passenger, verify the passenger details, retrieve the airline policy for cancellation rebooking, and it gives me step-by-step instructions on what I need to do. I can reject this plan or I can approve plan and run the agents. So once I approve my plan, it's going to go ahead and call the next agents and try to make sure that it goes through the step by step that we have mentioned above here with the research agent, and then the review and write and review and then give me everything back here. So it says flight recovery recommendation. Dear Jordan Lee, I'm so sorry to hear that your original flight, whatever, was cancelled. It gives me all the different things that are available. 4 alternate flights available. The reviewer score was 92 out of 100, which means it's pretty good. If there was no retries because the score was pretty high. Human approval before changing the booking. So it says recommend flight OA 205 and type approve booking here to execute. So go ahead and paste that, and I can now press enter and then say confirmed mock booking. It will say mock booking rebooking completed in the local training database. So this entire step went through, and we went through an entire flow. I can also look at the airline data that we have, the audit logs that we have. It created the plan was approved, then after that the workflow was completed and rebooking was confirmed. So everything is available right over here. I can also look at my ChromaDB here, which has SQLite, which will probably have all the data that we just entered and have it available here. Again, if you do not understand that, that's not a problem. What we did was we went an entire flow of multi agents and went through step by step each one of them and tried to help a customer rebook a flight using agents without having to call anyone, without having to go through all the different hassle that you have to go through. So this is something that you can build by the end of 7 days. So hope you enjoy it and hope you can go through this. If you understood everything and you know how to do it, I would not encourage you to take the course. But if you did not understand, we'll probably be going through each and every step in the next 7 days to complete this course. So I hope to see you on day 1.